Hello, future engineers, subscribers, viewers, and students. There is another video in structural analysis, particularly on indeterminate beams analyzed by superposition method. And I will also present other methods aside from this. So for this video, I'll present superposition method. So let's just find the external and internal reactions at the supports. EI is constant. Here is the given beam. So let's make the deflections and slope at the unknowns. So if we are going to remove this will be the contributions of the loadings. This is 21 kilonewton per meter load. So we have moment due to this loading at the fixed wall A, 21 times 8 times 4, so 672, and it is a second degree curve. For this triangular loading, we have 1/2 of 6 times 21 times 2, so 126 here. Then we imagine a concentrated load of 1/2 of 6 times 21, 63, and a couple of 126 kilonewton meter. Then that 126 kilonewton meter couple, so it is constant along AB, but the 1/2 of 6 times 21 or 63 kilonewtons times 8 is 504. Then the moment diagram by parts of this 28 kilonewton loads at the fixed wall at C first, 28 times 2, so you have 56. Then at B, 28 times 8, 224. Then at, so we imagine concentrated load of 28 kilonewtons at B, then a couple of 224 clockwise couple. That's why at A, this will be the moments. At B, we only have, at C rather, we have a couple of 28 times 2, concentrated load of 28. So that's why 56, and the moment you do the 28 kilonewton load at B would be 28 times 6, so that's 224 minus 56. So EI delta B due to the loads, we will only consider this part. This moment diagram by parts will have contribution to the deflection at B. So EI delta B load is, this is 672 8 squared over second degree plus 2. Then for this for the for this loadings moment 126 couple, length 8, so 8 square over 0 degree plus 2. Then this 504 kilonewton load, 504 8 square degree 1 plus 2. Then this has no contribution. And for this part, we have couple 224 times 8 square over 0 plus 2. Then for this, another 224 8 square over first degree plus 2. So calculating, combining EI delta B due to the loads is 112448 over 3 downward, kilonewton meter cube downward. Next, for the reaction, we have reaction at B, that's the moment diagram by parts. For reaction at C, that's the moment diagram by parts, and the moment is 14 RC. For RB, it's 8 RB at the fixed wall A. Then for the last, for the reaction at D times 19, so 19 RD. And because there is moment at D there, so we have moment at D. So EI, so we only consider this moment diagram by parts. which have contribution to the deflection at B due to the loadings. And it is upward. Anyway, we just equate upward deflections at B to the downward deflection at B due to the loadings. Upward deflection due to reactions. So beginning with this, we have 8RB, 8 square over 1 degree plus 2. So 8RB, 8 square over 1 plus 2. Next, plus we have a couple 6RC, 8 square over 0 degree plus 2. Imagine we have a couple of 6RC rectangular. So meaning due to the reaction at B, there is moment farther, which is 14RC minus 6RC, and that's 8RC. Then length 8 square over 1 degree plus 2. Then for reaction at B, so we have for the couple 11RD, 8 square over 0 plus 2. And for this 19 minus 11, 8RD moment, then length 8 square over first degree plus 2. So simplifying, then plus due to moment rather, moment, this is the moment diagram, MD, moment, length 8 square over 0 degree plus 2. So simplifying, we have 512 over 3 RB plus this one, 1088 over 3 RC plus this, 1568 over 3 RD, then plus 32 MD. Then equate, so that means 512 over 3 RB plus 1088 over 3 RC plus 1568 over 3 RD plus 32 MD equals 112448 over 3. Call that equation 1. Next, we compute EI delta C due to the load. So we consider moment diagrams for this part. So for this 672 here, due to deflection and due to additional deflection due to the slope at B. So quantity EI delta C due to the load is quantity 672 8 square divided by second degree plus 2 plus 6 times theta B, and theta B is moment 8 over second degree plus 1, then plus this third degree moment diagram by parts, 126 length 6 square degree 3 plus 2 due to deflection. This couple will have deflection at C and slope, deflection due to additional slope. So 126 length 8 square over 0 degree plus 2, and due to the slope 6 times theta B due to this couple load, couple moment. So 6 times 128 length 8 over degree 0 plus 1, then plus this triangular moment diagram 504 8 square over first degree plus 2 due to deflection, and do slope 6 times 504 8 over first degree plus 1. So that's already true. Next, we proceed to this moment diagram by parts. So imagine we have 56 load couple at couple 56. So plus 56 length length is 14 square divided by 0 degree plus 2, 0 plus 2, then plus quantity 224 minus 56, 224 minus 56, we have moment here at B, which is 392. Sorry, from 56 to there. So 224 plus 224 is 448 minus 56. So we have moment due to 28 kilonewton loads acting at C. That's 392. The length is 14. So 14 squared divided by first degree plus 2. And that's first degree straight line. So that's it. Then we add EI delta C due to the load is 86437.867 downward. Then for the reaction, uh, let's begin with this deflection and additional slope. So EI delta C due to the reactions is 8RB 8 square over first degree plus 2, that's reaction, plus 6 times 8RB, then length 8 over first degree plus 1 for the slope. So for this loading, it is 14RC, 14 square. Due to reaction at C, it will only produce direct upward deflection. So 14RC times 14 square over 1 degree plus 2. That's for RC. And for this moment diagram by parts, let's begin with a reaction. So imagine we have couple of 5RD and 19 minus 5RD is 14RD. Moment which is due to couple 5RD and due to reaction of 19 minus 5, so 14RD. So due to deflection only. So plus 5RD, 14 square over 0 plus 2 for the couple. Then plus 19 minus 5 again is 14RD. This triangular moment diagram by parts. Then 14 square over first degree plus 2. So that's for RD. Then finally for moment that the have to see that's MD, length 14 square over 0 degree plus 2. So moment D 14 square over 0 degree plus 2. So simplifying and equating to this value here, we have 1088 over 3 RB plus 2744 over 3 RC plus 4214 over 3 RD plus 98 MD equals 8647.867. Call this equation 2. And we will continue this on the next slide. So we note that the two equations. So next we will go to the load. So for this moment diagram by parts, we have 8RB length 8 square over 1 degree. So then slope is 6 plus 5 is 11. Is point 11 times theta is moment length over second degree plus 1. Then due to this moment diagram by parts, let's begin with this. Due to deflection, 126 times length 6 square over degree 3 plus 2, which is that. And due to the slope, 5 of the theta at C. So 5 times moment 126, length 6 divided by per degree plus 1. Then we proceed to this couple load. Deflection first, 126, length 8 square, 0 plus 2. Then for the slope, 6 plus 5, 11. 11 times 126 times 8, 0 plus 1. 500 due to deflection, 504, 8 square over 1 plus 2. Then due to slope, 11 of theta. 11 of 504 times 8 over first degree plus 1. Then due to this loading, let's begin with, it is only due to this. So the total moment at the wall is 448, then slope 3 times the theta at this point. For the deflection, it is 224 plus 224 is 448. Length is 8 plus 8, 16 square. 448, 16 square over 1 degree plus 2, and plus 3 times the theta at this point, which is equal to moment 448 length 16 over 1 plus 1. So simplifying, EI delta B due to the load is equal to 129.5 downward. Then EI delta B due to the reactions. This one due to deflection, 8 RD, 8 square over 1 plus 2. Then due to slope, 11 of 8 RD times 8 over 1 plus 1. For this diagram, 14 RC, length 14 square over 1 plus 2 due to deflection, and due to slope, 5 times theta. So 5 times 14 RC, 14 over 1 plus 1. This due to RC. Then due to RD, 19 RD, due to deflection, 19 deflection only, automatic. So quantity 19 RD, 19 square over 1 plus 2. Then due to moment MD, 19 square over 0 degree plus 1, plus 2. 0 degree plus 2. This is due to deflection at D due to the couple MD. So simplifying and equating to this value, so 1568 over 3 RB plus 4214 over 3 RC plus 6859 over 3 RD plus 180.5 MD equals 129,345.533 per EI. So the last equation, because there are 4 unknowns here, is due to theta at D, which is 0. So due to the loading, EI theta D is the slope at this point plus the slope at this point plus the slope at that point plus the slope at this point. So take note that the slope at the end of the load is the same if we consider individually. So for the first 8 RB, length 8 over 1 plus 1. So due to the load 672, 8 over 2 second degree plus 1. And due to this loading, moment diagram 126, length 6 over degree 3 plus 1. Due to this couple, 126, length 8 over 0 degree plus 1. Due to this moment, 504, length 8 over first degree plus 1. Then due to this moment at the wall 448, which is same slope at this point and at B, which is equal to 448, 16 over 1 plus 1, which is that, and that is equal to 8589. Finally, due to reactions, so we have EI theta B due to the reactions is 8 RD times 8 over 1 plus 1, then plus 14 RC times 14 over 1 plus 1. Then due to reaction B, 19 RD times 19 due to this loading reactions 19 RD times length 19 over 1 plus 1, and due to moment B, length 19 over 0 plus 1. Now simplifying and equating it to EI theta D left, which is 8589. So we have 32 RB plus 98 RC plus 180.5 RD plus 19 ND equals 8589. So solving equations 1, 2, 3, and 4 simultaneously gives us the following results. So RB is 131.019 kilonewtons. R sub C is 25.019 kilonewtons. R sub D is 12.684 kilonewtons, and the moment at B is negative 18.153 kilonewton meter. Then I want you to solve for AY by statics. It is equal to 90.278 kilonewtons, and moment at A is negative 128.74 kilonewtons. So that's it for this video. I want you to solve by statics moment at B and moment at C also.